Hello, so let's try this problem from vectors. It states a bicycle travels 4.60 kilometer due east in 0.410 hours, then 13.60 kilometers at 15° east of north in 0.740 hours, and finally another 4.60 kilometers due east in 0.410 hours to reach its destination. The time lost in turning is negligible. Assume that east is in the positive direction and north is in the positive y direction. So find the magnitude of the average velocity for this entire trip. So for this question, we have displacements and different displacements in different directions at different times. So our question is to find the average velocity. So the average velocity formula is total displacement over total time. So here we have delta R, the total displacement over total time. So now if we see the statement, so it states first it goes 4.60 kilometers due east in 0.410 hours. So let's see. So it states that the first it goes, suppose this 4.60 kilometers, and this direction suppose is your east. So then after this it goes 13.60 kilometers. So it goes, this is our 13.60 kilometer, and this is at a, this is the y-axis, and this y-axis is actually upside is your north. So this angle here is making, with the y-axis it's making 15°. So with the x-axis it's gonna make 75. So here the angle is 75°. So now after this it states that it again goes 4.60 kilometers due east. So again it travels 4.60 kilometers. So these are the three different displacements during this whole path. So for that we need to find the total x displacement and the total y displacement for this whole trip. So our total x displacement, so the total x displacement is going to be 4.60 kilometers, 4.60 kilometer plus 13.6. The x component for this is going to be 13.6 cosine of 75° plus, again the third is 4.6 kilometer. So 4.60 kilometer. So when you will calculate this whole, and make sure when you are calculating cosine of 75° on your scientific calculator, it should be in the degrees, not in the radians. So when you will calculate this, it will be 12.72 kilometers. And similarly we can go and find the total y displacement for this entire trip. So y displacement, so for this first displacement there is no y component, so it's gonna be 0 plus 13.60, so 13.6 sine of 75°, and again for this third 4.60 kilometer in green, there is no y component, so it's again gonna be 0. So when you will calculate this on your calculator, you will get 13.14 kilometer. Now, so we have the x component, we have the y component of displacement. So now our total displacement will be equals to under root of this 12.72 square of this plus 13.14 square of this. When you will calculate this whole thing, you will get delta R equals to 18.29 kilometer. So now the V average is delta R over delta T. Delta R we calculated 18.29, and the total time is first is 0.410 hours, plus it took 0.740 for the second, plus again 0.410 hours. So when you will calculate this whole thing, you will get 11.7 kilometers per hour. 11.7 kilometers per hour as the average velocity for this entire trip. So the next part is, what is the direction of average velocity for the entire trip? And so we calculated our x component of total displacement. R of x was 12.72 kilometers, and R of y, the y component of total displacement, was 13.14 kilometer. So now since we need to find the theta, so theta has this formula, tangent inverse of the y component over x component. So this is going to be tangent inverse 13.14 divided by 12.72, and I got it 45.9 north of east. So the V average we calculated, V of average was 11.7 kilometer per hour, and the theta for this case is 45.9 degree north of east. That is the theta value. Thank you.